Okay, now we are going to move on to you guys' favorite part, the oddballs. The times when it doesn't work out like it usually does. This is when we get the no solutions, the all real numbers, when we don't just get x equals p equals or x is greater than or p is greater than, when we get something out of the ordinary. So you can't always tell by just looking at it, but let's do what we know how to do. Step one is let's combine like terms. So right here I have 2p plus p, so I'd be left with 3p minus 5 is greater than 3p minus 7. So now I want to get all my variables to one side of the inequality sign. So I'm going to subtract 3p from this side to get rid of it. You're going to notice if I subtract 3p from that side, I have to subtract 3p from this side. And when that happens, I cancel out 3p's on both sides. So I'm not left with any variables. All I'm left with is negative 5 is greater than negative 7. Now I know when we did equations, like, okay, negative 5 doesn't equal negative 7, that would be no solutions. Not the same here, because this is inequalities. Read what it says. Negative 5 is greater than negative 7. Is negative 5 greater than negative 7? Yes, it is. So this is an instance of an all real numbers, where any number you plug into R, any number you plug into P will make this true on both sides, any number in the world. So how do you graph this? Pretty simply, I just use 0 because it's the middle of the number line. We're going to circle that. It's included because all numbers are included. And we're just going to graph going to the left and it's going to the right. It's going both ways. Every number in the number line is included, so going both ways. So that is an example of all real numbers because negative 5 is greater than negative 7. Let's look down here. I have 6 times the quantity of x plus 3 is less than 5x plus 18 plus x. Step 1, let's distribute. I have 6x plus 18 is less than, and let's go ahead and combine like terms here. It's 5x plus x would be 6x plus 18. And you might notice already that we have the same thing on both sides of the variable. It's the exact same thing on both sides. If you want to take it a step farther, we can. Maybe get all of our variables on one side. Minus 6x, minus 6x. They cancel out. They cancel out. I'm left with 18 is less than 18. Well, is 18 equal to 18? Yes. But is 18 less than 18? Is that a true statement that 18 can be less than itself? No, it can't be less than itself. So this is an example of no solutions. So we can just put the no solution symbol, or we can write no solutions. For the graph, I'm not too worried about it, but if you want to graph it, the easiest way to do it is just to put your 0 there, circle it, which means don't fill it in because it's not part of the solution set, and don't have any errors at all. There is no solution to this, there is no graph. That would be the answer to that one. So when you do these, you have to read your answer and see if it's a true statement. Negative 5 is greater than negative 7, all real numbers. 18 is not less than 18, so it's no solutions. These are the oddballs. Let's do 2 more. On this top one, we have 2 times the quantity of t minus 3 is greater than 2t minus 8. So let's distribute. I'm left with 2t minus 6 is greater than 2t minus 8. Subtract 2t, subtract 2t. I'm left with negative 6 is greater than negative 8. Is that a true statement? Is negative 6 greater than negative 8? It is. So that'd be an all real number solution. So graph 0, fill it in, and have my graph going both ways.